collections. So Java collection is very important topic in the Java, and it is widely being asked in the interviews, and it is widely being used during the coding as well. So it is very important topic to understand for everyone working in the industry using Java, right? So what is the agenda for this particular series? So agenda of this particular series is we are going to discuss about introduction to Java collections, which we have already covered in the last lecture. So I'll be like quickly covering it again, right? And then we are going to discuss about various implementation of list, set, and map, which are like three collections in Java. List is one collection, set is another, and map is the third one, right? So these are the interfaces. Corresponding to these interfaces, we have implementation provided by Java, that is ArrayList, LinkedList in case of list. For set, we have HashSet, LinkedHashSet, and treeset. And for map, we have HashMap, LinkedHashMap, treemap. Though they are like multiple implementation, but we are going to focus on these implementation because these are widely being used during automation. So later we are going to talk about sorting of collections as well using comparable and comparator. So we will be discussing about the comparable and comparator as well as part of this series, right? So let us quickly recap what we covered in the last lecture. So what is Java collection? So Java collection is nothing when we want to organize the data under one umbrella or under one unit. So we have one provision, that is collection. So using collection, we can store multiple data under single unit, right? So for example, we have integer, we can store int a equal to 10, but if I want to store multiple integers, I want to store age of people, I want to store name of people, so how I will store? So that is possible using the Java collections. So as I discussed, like we have list, set, and map, and in these collections we can store heterogeneous as well as homogeneous data. Heterogeneous is different type of data, meaning we can store integer, string, or other type of data within the collection, but this is not recommended. It is recommended to use only homogeneous data, meaning we should store only one type of data in one particular collection. So let us quickly try to understand the hierarchy. So we have iterable interface at the top, and collection is another interface which is extending this iterable. Then we have set, list, and queue. So queue is out of scope as it is not mostly used in automation, but in case you want me to cover, I can cover it, right? So please provide a comment for the same, right? So in list, as I mentioned, this is a interface. So iterable is an interface, collection is another interface which is extending iterable, and then list is another interface. So these are all like interfaces, right? Now when we work in Java, interfaces are nothing but these are just declaration of methods. So we have the method signature only, right? Method declaration, I mean. So to provide the implementation or to provide the definition to those methods, what we need to have concrete classes. So we have multiple classes which are implementing list, but we are going to cover ArrayList and LinkedList because these are widely used during the test automation. Similarly, when we want to store the values in the set, so we have set interface, and we have like multiple classes, and we are going to cover HashSet, LinkedHashSet, and treeset as well. So treeset also will be covering, right? So list is used to store the duplicate elements. So suppose I want to store the name of employees of organization. So what I want is I want to store the duplicate name. So for example, there can be prince, multiple employees with name prince. So I want to keep a store of that. So in that case, I'll be using list. But what if I want to store only the unique name, right? I don't want to be bothered. I don't want to be bothered about like whether like how many name of prince name employee are there, right? But I want to get a single count. So in those cases, we use set. So set is to uh, like store the unique values. So we will try to understand both the cases in this series, I mean, right? Then coming to map doesn't fall under iterable, so we cannot utilize the methods of iterable, right, for map, for the purpose of iteration. So map is an interface, though it falls under Java collection framework itself, And then we have abstract map, which is a class providing the partial implementation. Why I'm saying partial implementation? Because this is abstract map. So when there is a abstract keyword, right, it means that this particular class will have provided the implementation of some of the methods available in interface, but it should have kept some methods as unimplemented or abstract, right? So why? Because it would have given the liberty to HashMap, LinkedHashMap, and treemap to provide their respective implementation. So map is an interface, abstract map is providing implementation, and we can say partial implementation. So for rest of the methods which are not implemented in abstract map, so HashMap, LinkedHashMap, and treemap would be implementing them depending on their need, right, as per their logic, right? So as I mentioned that in today's lecture we are going to talk about list, and under list we are going to cover array list. So list is a one type of collection in Java to store the list of elements. So as I discussed, I want to store, for example, list of names or list of age, right? I want to store age of employees. I want to store name of employees, right? So for those purpose, we use the list interface, right? And under list, as this is the interface, so we have two concrete classes that we are going to cover as part of this series: ArrayList and LinkedList. So ArrayList is based on the array, dynamic array, right? So in case of array we have the fixed size, but in case of ArrayList we don't have the fixed size, and as we add the values into list, its size grows automatically, right? While linked list is based on the doubly linked list data structure. Okay, so in the next lecture we'll be covering the linked list as well, right? Now I have refined it further for the list only, this diagram. So we have iterable interface. So this iterable interface has few methods that we will be discussing and useful for the iteration. Then we have collection, which is another interface, so it would be having its own methods, right? And list has its own method. So all these methods are declared because these are interfaces. Now ArrayList would be implementing all the methods of iterable, collection, list, and yeah, iterable method. So for example, iterable has let us say two methods, collection has let us say three methods, and list has three more methods. So 2 3 5, 5 plus 3 8, so 8 methods array list would be implementing, right? Similarly, linked list would be also implementing. So array list would be implementing based on array concept, sorry, and linked list would be implementing based on the doubly linked list concept, right? So to refine it further for the array list, so we have iterable, which is the interface, then we have collection, we have list, and array list, right? Now as we have understood that this is the hierarchy of array list, let us try to understand it from the programming side. So I have created one basic Maven project wherein I have created one main method. So what I'm going to simply use, so I'm simply going to, first of all we need to understand how to initialize the list, right? So as you know that in Java we cannot create object of interface. So what we need to do, we need to create the object of class. So as we are going to discuss about ArrayList, so let us create the object of ArrayList, right? So this is how we create the object of it. And now we have created the object, so we need to assign it to some value. So what we can do, we can either create like this ArrayList and list of names, and I'm doing the assignment, right? But here it is saying angle bracket, so we can use without angle bracket as well. So let me remove this angle bracket, right? So this is very generic way of initializing the elements, initializing the array list. So as you see that I can define like this, but I can define like this as well, right? Why? Because list is the parent and array list is the implementation of this class. So as per Java concept, we can provide reference variable as parent, and we can create object of child and provide it to the provide the reference variable as parent, right? So this is what we have done. So we just discussed that we can store heterogeneous data, so we are going to discuss about that part. What is that heterogeneous data? Dot add, and let us say 32, right? Now if I will try to print this particular list, so what will happen? So let me run it. So we'll see it will print the prints as well as 32. So we were able to store like heterogeneous data, but it is not recommended because we will have typecasting error and all. So what is recommended? So we are recommended to use a generic, right? So what do we mean by generic? So we should store a specific type of data type. So let us say I want to store names of employees. So for that purpose, because names used to be in string, so this is how I need to provide a generic. Similarly here also we need to provide a string, right? And now you will see that it is giving error because it is expecting string, but we have provided integer, right? So what we are going to do, let us say I'm going to provide Amit. Now if I'll run, so you see that we are able to like print the values of employees, right? So this is one way of creating the list. So if there is a need of, for example, list of integers I want to create, so that is also possible, right? If in case I want to store list of integers, right? So that is also possible. So list of ints and new array list. And remember one thing, that on the left side it is mandatory to provide the generic, but on the right side it is not mandatory, right? So let me show you. List of ints dot add to list of ints dot add 5, right? So this is how we can store the integer. So now I'm going to print a list of integers, whatever been stored in the list. So I'm just printing the collection. So this is how we can print the collections, right? Now the next question is like how to for example, how to create a list of collection with predefined value. So that is also possible. So for example, I want to store list of employees, and I'm going to give it name list of employees, and what I want is new array list, and list dot of is one method that we can use. So I can provide Amit comma Prince comma Sumit, right? So this is how I am able to create the list with predefined values, right? So now I'm going to run it again. So this time I'll get Amit, Prince and Sumit as well, because I'm printing this particular list. So you see that we are able to create. Now the next question is, can we convert an array into the list? So that is also possible. So first of all, how we create an array. So how we define, as we discussed, that array is a fixed size, so we need to define the elements or the size, right? So let us say I'm going to provide 5 comma 6 comma 7 comma 8, right? So we have provided extra comma. So now how to convert this into list? So there is a arrays class. Using arrays.asList we can do this. So we need to simply provide array here. Now the return type of this as list is a list, right? Java util list, right? As we are providing integer, so what we can do, list of integer and list of integers. So this is how we can convert the array into the list. So now I'm going to print list of integers. So we see that we are able to convert an array into the list. So these are the concepts which would be useful for solving the coding problems as well, right? Now we have discussed about like adding the values into the list. We have discussed about how to initialize the list. Now the next step is how to iterate it, because how to iterate it, because because we have list of elements. So if in case we want to get the value, right, from the list, so what we need to do, we need to iterate them. So there are like multiple ways we can iterate it. So let us talk about iteration. So as we have already discussed that list falls under list extends collections. So there is another and collections extend iterable, right? So iterable has two methods. So we have first of all iterator, right? So using iterator we can iterate it. This is one way, right? So there are like multiple ways. So let us discuss the iteration using iterator. So how we can do use this. So first of all, let us say, let us consider the basic one. I'm just commenting everything here, right? And I'm going to use this first one, right? List of names, where we added Prince and Amit, right? So we are going to iterate this, right? So how we will do this? List of names dot iterator. So when we'll do iterator, it will say that you need to have some assignment on the right side. So what we need to do, we need to create iterator of string, because, and we can give it name iterator itself, right? So what we have done, we have converted this list of names into the iterator, and using this we are able to do this, right? Now in iterator we have some method iterator dot has next. So what does it do? It will check whether we have next element or not. If yes, then it will print. And there is another method in iterator, that is iterator dot next. So next will print the value, right? So what it will do, first of all, because we have converted list of names into iterator, this way we have created object of it, right? And now when we will try to print, it will print the values one by one. So previously it was printing in square bracket, but this time it will print one by one. So we'll see that. So you see that we can print the values, so we are able to extract. So this is one way. Second way is using the for loop, right? So we can use normal for loop, where we can define like this: I less than, and as we have list of names, so there is a size method in list, and I plus plus. Now what we can do, list of names dot get of I, because we discussed like array list is based out of array, right? So we can get the indexes dot, for example. So what will happen with this list of items dot get I? So list of items dot 0th index value will be printed, then first index value will be printed, right? Now we will see that we are again able to print, right? So this is iteration, sorry, using normal for loop. Now we are going to cover iteration using enhanced for loop, or some people say it like for each loop, right? So let us discuss about it. So in case of for loop, enhanced for loop, we simply need to provide the list of items on the right side, and on the left side what we need to provide, because list of names is what, this is string. So first of all we need to have string as a data type, and then we can provide the variable. So this is the variable, and this is the list of items. So it will serve list of items one by one to left side, and now we can use this particular variable, right? So if I'll like execute it again, I'll get the same values, right? So this is how we can iterate the list in multiple ways. Okay, now as we have already discussed that we are going to discuss about the real-time application as well, where we can use this particular like list, right? So let me quickly go to this particular site. So this is one site. So what I will do, I'll store the values of this last name of this particular column. So how we will do it? So first of all, um, we need to create a setup, basic setup. So I'm going to comment the rest of the site, rest of the section, right? So first of all, what we need to write driver equal to new Chrome driver. We are going to cover with Chrome driver, right? And as you are aware, this Chrome driver would need one Chrome driver exe. For that purpose, we need to download it. So we will be using the like some automated way. So WebDriver manager dot chrome driver dot setup. Using this, we can download the Chrome exe, right? So in case you are not aware on this, I have already created a series on this WebDriver manager and Selenium manager. I'll be sharing the link of same in the I icon to understand how it manages the download, right, of driver. Now the next step is driver dot get. So I'll provide the URL here, right? Now what is the next step? Let us inspect these elements. So this is a table. So what we'll do, we will need to find out the XPath. So table is the tag with ID equal to table 1. You see this is the table 1, right? I'm simply providing the XPath here. Now we got this. So what we need next? We need the body. We got the body. Now we need the rows, right? So what we will do, driver dot find elements, because you see that there are like multiple nodes, so we need to store it into the list. So using find elements we can get the list of elements, right? So I'll simply provide by dot xpath because we are using xpath, and what we will say, we will call it like list of web element because it will store the list of web elements. So rows, we can say it name like rows, right? Once we have got the rows, so the next step is to get the column, right? Because under each row we have first column that we need to capture. So how we will do that? So we will again use the like enhanced for loop. So I'll be keeping web element on the left side, and I can give it name row, and on the right side we have rows. So one by one, rows will serve the value to row, and row will have the value, right? Now what we need to do, we need to again use driver dot find element by dot xpath. So we can find element from the element, right? So we got one element, so using element itself we can again find it. So what we need the td. So this particular element, whatever the row is, right? So we need to use row actually here. We don't need to use driver, right? Because we got the element, and from this element we are further trying to get its child element. So this is how we can do it. Now what we next, we need the get text, because this is the text. And now what we want is, as per the initial requirement, we want to store this. So in order to store this, what we need a list. So I'm going to create list of string because these are the string values, and list of last name and new array list, right? So list of names. So how we can do this? List of names dot add, right? So what we have done, we first of all we got the rows and we are iterating the rows element, and from this row element we are trying to find the child element by td. This is the first element, and from that we are getting the text, and now we are storing that text one by one into the list of last names list, right, which we have created. Now at last we are going to print this. Okay, so there is a minor miss. I'm going to use the driver.quit as well so that it will close the window. So let me run it once again. So we'll see that a Chrome window will launch and it will enter the URL, and then it would have stored the values. So what we have done, so we are able to store Smith, batch, do, and Conway. Let us confirm the same. So what are the values? Smith, batch, do, and Conway, right? So we are able to store the values into the list, and we are able to print the values as well. So this is how we can use list, array list I mean, in the test automation framework. This is how we can initialize, this is how we can add the values, and we can, like, there are like multiple operations we can perform in list that you can explore. So we discussed about add operations, so you can use I mean remove as well to remove the values. So they're like multiple operations. So how to check that? So simply you need to do one thing, list of names dot. So these are the methods which are available in the list. So we discussed about size as well, right, for the iteration part. So today we are going to cover linked list, which is another way of implementing the list interface, that is linked list. So in linked list, the underlying data structure is doubly linked list. So we will try to understand doubly linked list at high level as well. Okay. So before we move on, let us understand the list hierarchy in the collection framework, which we have already covered as well in the last lecture. But let us quickly recap it, right? So we have iterable, which is the root node in the Java collection framework. Then we have a collection interface, which is extending this iterable interface. Then we have a list, which is the topic that we are covering right now, interface, which is further extending collection. Then we have like classes implementing this list, ArrayList as well as LinkedList. Uh, okay, so ArrayList is already covered, as you know, and LinkedList we are going to cover today. Now let us try to understand LinkedList as well. So now you notice that we have iterable, which is the root node. Then we have collection. We have then list, which is extending collection. Similarly, we have queue as well, which would be having functionality related to queue, which follows the FIFO data structure, first in, first out, while DQ have both the ways, meaning it does not only follow first in, first out, but it works in the reverse order as well, right? Now coming to the linked list. So linked list is actually following the multiple inheritance concept of Java, due to which it is implementing list as well as DQ interfaces of the collection framework. Okay, so as to utilize the functionality of both list as well as DQ. Okay, because of this, when we will be creating the object of linked list, so we can assign it to any parent, because DQ is also its parent and list is also its parent, right? So that is what we are going to cover as well, right? Then we are going to our few more operations as well. Before that, let us try to understand how ArrayList look like and how linked list look like, right? So when we create an array list and when we add the elements, so what happens is, as soon as the array list is created, a contiguous memory location is assigned, right? So for example, by default, let us say a size 10 is assigned. I believe this is the default value, default capacity is assigned. So let us say we are adding 10 members, so they would be at the contiguous location, right? So they would be, for example, this is having 20 address, this would be having 21 address, 22, 23, 24, right? And corresponding to that, index would be assigned. So this will become 0th index, it would be first index, second index, third and fourth, right? So the values are stored in the contiguous location. Contiguous location means the address would be continuous, right? We discussed this would be 20, this would be 21, right? Now in linked list, how it works. So in linked list, as we have mentioned, that it is based out of doubly linked list. So doubly linked list data structure. So how doubly linked list data structure work? So first of all, let us try to understand the main building block, which is a node, right? This is a you can consider this is one node, right, which has three partitions: first partition, second and third, right? And when we create a linked list, the first node when we'll be adding, that will become a head, right? That would be the first node, right? Now this as it has three partition, first partition, second and third, right? So first partition stores the address of the previous node, but as this is the first node in the linked list, so it won't be pointing to any other node, so it is having address null, right? Now talks about the second partition, so it stores the actual value, whatever the value we want to store, it would be adding it, right? Next, this particular thing, it would be storing the reference of or storing the address of next element, right? Similarly, this particular node will also be storing the reference of previous node, so that they maintain or they refer to the addresses of each other. So in case of ArrayList, they were contiguous addresses, so it was easy for them to track, they don't need linking, while in this case we need linking. That's why they are storing the extra memory, they are having extra memory, and which is used to point to the next and the previous memory location of the nodes, right? And in case of linked list, this particular thing is the tail, right? So we travel from head to tail, right? But as this is the doubly linked list, so we can travel from the tail and tail to head as well, right? And as this is doubly linked list, that's why it is storing, this particular node is storing the address of this one, and this particular one is storing the address of previous one as well, right? Because it is storing the address of next one as well as previous one, that's why it is doubly linked list. While in case of single linked list, we won't be having this particular arrow, meaning it would be, the node would be storing the reference of the next elements as well. But as linked list is using the doubly linked list data structure, so this is how it looks like, right? So we will be discussing about add, how to add value and how it differs. Then we will be discussing about removal as well, right? Now let us try to understand from the demonstration point of view, right? So as we cannot create the object of list, so what we'll be doing, we will be creating the object of linked list, right? So linked list, right? How to create the object of linked list, new linked list, right? As I mentioned that it is like child of both, so what we can do, we can, let us say we create the list of like linked list of string, because let us say we want to store only the list of elements, right? Now uh, what I can do, I can store it in either into the list, right? So I can give it name list, right? Similarly what I can do, I can do like this as well, I can convert it into dq, right? But I'll give it name list one. So you see that the object of it, I can assign it to the list as well as dq. Why? Because this linked list is implementing list interface as well as dq interfaces. Let us try to understand from here, right? So I went inside the linked list. If you notice, it is implementing list as well as dq, right? That's why it is able to, we can assign the object of list, linked list I mean, to the list as well as dq. Let us go inside. So dq has its own methods, add first, add last, right? Similarly list would be having its own method, right? So let us say size is empty, contains iterator to array, right? So these are the different methods of list, right? So now what we will do, we have initialized the linked list. Now the point is to add it, right? So by default, when we will, for example, create the values, let us add the one value and I will try to print it first, right? List, and I'm going to run it. Now you see that it has added Amit. By default, if I'll do list.add and prints, what it will do, it will add this particular element at the end of the node, meaning it would be adding here at the end, right? So let us try to understand the same. If I'll run this, what will happen? So you see it added Amit comma prince. Now the next thing is, so like how to, so we have method of list dot add first as well, but that won't be visible to us. Why? Because even though we created object of linked list, but we are assigning it to the list parent, right? And list does not have this method, right? Add first, because add first is the method of dq. So what we can do, so there are two ways. One way is either I can convert this into linked list directly, right? Because we are creating object of list and we are assigning it to the linked list reference variable as well. Now by default, if I'll, for example, try to add uh, list dot add, and I'm adding last one. So what will happen, it will so what will happen, it will add it to the last by default, right? So you see it added at the last, and then there is a method add last as well. Now I'm going to add last too, right? So what I want to show you, I'll just tell you, right? So you see, you will see that Amit prints last two, right? Now we added last two as well, right? So this is how it added the value at the last, but we removed that particular value as well. Just a moment. List dot last one. I didn't want to remove that. So list dot add one. I'm just going to reverse some operation, right? So what I want to show you that this list dot add will add the value at last, and this add last will also add the value at last. Okay, so we will try to understand that, right? So we'll see that Amit prints last one, last two. Why? How it is happening? So if I go inside this add, it is calling the link last method, right? Which is to link the node at the last, right? Similarly, if I go inside at last, it is also calling the link last, right? So link this add and at last are the same. Now, what if I want to add the value at starting? So for that purpose, what I'll be doing first, now, when I'll be executing this, what will happen? This particular value will be added at the first, right? First, Amit prints last one, last two. But if I want to add it somewhere um on the, like for example, this is 0th index, this is first and second, right? So for example, if I want to add and on first index, let me give it name first index, right? What will happen in that case, right? So you see that on the first index, this value got added, right? Now what if, now let us try to understand what actually happens in case of this, in this case, I mean. So when we are adding a value on the first index, this is 0 first, right? What will happen in that case? That first of all, the linking will be like disconnected. So for example, this one will be connected. So whatever, for example, object 2 was referring to object 3, this particular block was referring to the address of this object 3, and in return object 3 was referring to the address of object 2. Now what will happen, as soon as we will add it, it will simply disconnect or remove these references, meaning it will remove the address of this node, and it will start, it will add the address of, it will store the address of this particular node now, right? Similarly, this particular node in return will be storing the address of this. Likewise, same thing will happen here as well, right? Now the next thing is, so for example, let's say I want to, you I want to remove it, right? So how to remove it? So by default it will be removing it from the last, I believe. And what if I want to remove from the first index, right? So now let us see. So first index thing should be removed. You see, first prints last one, last two. So whatever the value we added, that got removed. Now let us try to understand what happens in case of remove, right? So suppose we tried removing from the first index. This is 0, this is first, and this is second, right? So what will happen in this case? So what will happen, first of all, this particular node previously was storing address of this one, and then this particular thing was storing the address of this one. What will happen? It will erase the address of this, and it will now store the address of the next node, right? And in return, this will also store the address of this one, right? So this is how it takes place, right? Right now, as we have understood like how to add the values into the list and how to remove the value into the list, now it's time to understand how to iterate it, right? So how to iterate it, for that purpose what we will do, so like as discussed last time, we have multiple ways. Let us discuss the first way. List dot iterator, and what will happen in this case? Iterator of string, because we have strings, so iterator list dot iterator, right? Now while iterator dot has next, which will check whether it has values or not, this one what it will do, it will print the values. Iterator dot next, right? Now we will try to print it, right? So it will print the values one by one now, right? So these are used for example when we want to use it, right? Now first Amit prints last one, last two, right? Got it? So as I mentioned that it is using DQ as well. So in DQ we have descending iterator as well. So let us try to understand descending of iterator as well. Descending iterator, right? And iterator of string and iterator 1, right? Right. Now when I will try to print this, iterator 1 dot has next s out dot iterator 1 dot next. So we'll see what is the difference. I believe it should print in the reverse order. So we see that it has printed the values in the reverse order. So in case we want to iterate in the reverse direction, so we can use this one as well, right? Now the next thing is how to iterate it using for loop. So it would be similar to that only, right? So for int I equal to 0, I less than list dot size I plus plus, right? This is one way. S out list dot get of I, right? And it should, I believe, print the values, right? So it will print the values. Now the next thing is how to iterate it using the enhanced for loop, right? So similar to that, as this is list which is containing string of values. So string, this is name because this is a list of names. So like this, now what I can do, name, so it will print the values of name step by step. So you see that we're able to like print the values, right? So we discussed about like how we can initialize the linked list and how it is different, how we can add the values at first, how we can add the values at last, how we can add the values on a certain index, how we can remove the values from the certain index, and we discussed about how it internally happens as well, right? Now let us try to understand the differences between the array list and linked list, which is the most widely asked question in the interviews. So as we discussed that ArrayList implements the dynamic array, right? And linked list implements the doubly linked list, right? And in case of manipulation, in case of ArrayList, I mean manipulation is time consuming, because suppose if I want to add a value onto a particular index, what would be happening? So suppose I have 100 size list. What would be what would happen if, for example, I want to add it onto the 50th index? So it would be shifting all the bits by one step, meaning the shifting of like elements will take place and it will be assigned to the new memory. So it is time consuming. While in case of linked list, it is efficient because there is no bits shifting, right? Because we discussed, it will simply disconnect the link or remove the link and it will start pointing to the new node, right? Even though it would be traversing till that particular node through the indexes. So for example, it will go up till 50 and then it will like remove that particular node, and or for example if we want to add, what it will do, it will point to that node and that node will in turn start pointing to the next node, right? So there won't be any bit shifting. That's why manipulation is easy and efficient, I can say. So insertion is slow here, as I discussed. Like if we want to add some value onto the index, so it will lead to have bits shifting. That's why insertion is slow. While in this case, insertion is fast, right? Because as I discussed, that's just it is just removing the addresses of previous and last memory. Deletion is inefficient again, because if you will delete again, it will lead to have bits shifting. So for example, if I want to delete some value from the middle, then what will happen, it will again shift the like the values, the previous values to the like just one step back, I mean, right? Deletion here is efficient, as we discussed. Like it will simply disconnect the links or remove the addresses of that particular node and it will start pointing to the previous node, right? And this array list, as we discussed, that it implements list only, so we can only utilize the like methods of list, right? While it implement list as well as dequeue, so it uses methods of list as well as dequeue. which we discussed, right? So we can assign the object of um, linked list to the list as well as dequeue, because both are the parent, which we discussed, right? Then where can we use array list, right? So it is used where we want to access and store the data. So as where there is a need to just store the values and we want to get the values. So for example, if I want to get the value for particular index, so what will happen for that, corresponding to that particular address, we will get the address, right, of that memory address, right? And we will be able to get the values, right? So random access is easy here, and if we want to get the values, then array list is the best suitable, right? But what if we want to add, there is a need of adding and removing the elements in between, then this linked list is the beneficial. And in case of array list, less memory is used, because we would be having only one memory address where we store the values. But in case of linked list, as we discussed, that we have three partitions, so that will lead to have more memory, because they would be storing the values address of previous as well as next node, right? Now the next question is, which one is useful for the test automation? Okay, so there is a spelling mistake, sorry for that. So which one is useful for the test automation? So as per my experience, we usually store the values and we access it. Sometimes we get it through the indexes by running the for loop. Sometimes we use the enhanced for loop, right? So usually we store the values and like retrieve the values. So for test automation, array list is a suitable. But what if there is a need to modify the list on the fly? Then I'll recommend to use the linked list. So let us move on to the next collection in the series, that is set. So in case we want to store the unique elements, so for those purposes we use the set collection. So as set falls under Java collection framework, so as we know, we have iterable, which is the root node. Then we have collection, which is extending the iterable interface. Then we have a set, which is extending the collection, right? So as I have mentioned, that set is used to store the unique elements, and this is the interface. So we need some concrete class. So we have HashSet. So HashSet provide the implementation of this set interface, right? Now using HashSet, we can store the unique values, but there is a downside of HashSet. It does not maintain the insertion order. So whichever way we are adding the values into this HashSet, it won't maintain the order. So what if we want to achieve the insertion order maintenance as well? So for those purposes, we go with the linked HashSet, right? And then in case we want to maintain the sorting, then we go for the tree set, which comes by this hierarchy. So we have sorted set, which is extending set. Then we have navigable set, which is extending sorted set. These are the interfaces. Now we have tree set, which is providing the implementation. Now let us try to understand all three and what they are using internally. So HashSet actually uses HashMap internally, and as it is using HashMap internally, that's why it is not maintaining the insertion order, because HashMap also does not maintain the insertion order. And LinkedHashSet internally uses LinkedHashMap, that's why it is able to maintain the insertion order, because LinkedHashMap also maintains the insertion order. So HashMap and LinkedHashMap will be covering in the next lecture. There you will get more understanding how they maintain the insertion order and all, right? Then comes treeset. So treeset uses tree data structure internally to maintain the sorting order, that is ascending order. Okay. Now let us jump onto the HashSet. So when we want to store unique values, but we are not worried about their order, then we go for the HashSet. Now let us go by the demonstration. So I'm going into the project. So I have created one class and having one main method. So let us quickly create the object of HashSet string. HashSet of string I'm creating, right? Because I am going to store the list of sorry, set of unique values. So what I will do, because now I have created the object, so the next thing is I need to assign it to some variable. So for that purpose, what I'll be doing, set of string, and let us give it names, right? Now as we discussed that it uses map internally, let us try to confirm the same. So you see it is using the hash map, right? Now What we will do now, let us try to understand its unique properties. So for example, I'm adding prints, right, and I'll re-add prints, right, and now I will try to print this. So names, right, so you see that it is adding or containing only one value. It won't care about how many values we have added. Now the next thing is it does not maintain the insertion order. So for that purpose, what we are going to do, so let me replace it with Amit and give it names.prints Amit, Rakesh, and likewise Sumit, and let us say Ishan, right, and let us give one line to read it actually. Unordered names using HashSet, right. Now we will try to print it, right. So you see it is not maintaining the insertion order. Ishan was added last and Prince was added first, so it is not maintaining the insertion order. Now let us move to the linked hash set in order to maintain the insertion order. So I'll simply copy paste this and replace this with the linked hash set, and let us, before moving on, and let us give it name ordered names, right, and ordered names, replace it with ordered names, and let us give it name ordered names using linked hash set. Right, before we move on, let us try to understand what it is using internally. So as I mentioned, this is the object, and when I go for super, which is the calling of parent, so it is initializing the linked hash set hash map in this case. So this is why it is able to maintain the insertion order. Now let us rerun it once again. So we will see that this is unordered and this is ordered, meaning it is maintaining the insertion order. So Prince added first, so Prince is appearing at first, Amit is adding second, it is appearing at second. Right, now what if I want to maintain the sorting order? So for that purpose, what I will do, simply I'll copy paste this and give it name sorted names this time, and replace this with treeset, because treeset is responsible for maintaining the such like sorting order. So I'll simply replace this with this, and let us give it name sorted names using treeset, right, and let us print the sorted names as well. Now let us run this. So you see that it is now maintaining the insertion order. First of all, this is unordered, this is ordered the way we are adding, and this is sorted one. So A is coming first, then I is coming after it, then P, then R, and S. This is how it is maintaining the insertion order, I mean sorting order, sorry. Right, now let us comment this and let us discuss about the like iteration. So yeah, I just simply want to show you sorted names dot get. So actually it does not maintain the indexes, so we cannot use the normal for loop in this case. Okay, so what we are going to use, so the first thing is we will be using the enhanced for loop. So I'll simply copy this. What is this? This is set of strings, right? And so in enhanced for loop, what we need on the left side, we need um, the data type which is stored in this set. So I have simply, this is set of names, and this is one by one it will be served here. So from here to here, like it is having, for example, 5 elements. So first element will be served here and it will be stored in name, and likewise rest of the element will be done like this, right? Now this is one way, right, to iterate it. So we will see, so it is iterating like this, right? Now the second way is using the iterator, because set also falls under the iterable interface, and iterator is the method of iterable interface, so we can use iterator as well. So how to use that? So first of all, I'll simply call this sorted names dot iterator, and as it contains set of string, so what I will do, I will create iterator of string, right? And let us say give it name unique names, or let us give it name iterator. Very simple. Now what is next? So first thing is we need to check whether this particular set has value or not. So using has next, which returns boolean, it will return us true or false. And then we can use the next method, iterator dot next. What it does, it prints the values, right, one by one. So this will check whether it has value or not, and this will print the values. So now let us run this. So we see that we are able to iterate this. So this is what I wanted to cover as part of this set collection lecture, I mean. And let us quickly recap. In case we want to store duplicate elements, we can either go for linked list or array list. But if we want to store unique values, then we go for set. And in set itself, if we want to store unordered data, then we can go for HashSet. And in case we want to maintain the insertion order, we should go for LinkedHashSet. And if we want to maintain the ascending order of sorting, then we go for the treeset. Thank you for watching, and please like, share and subscribe. Thank you once again. So in today's lecture we are going to cover very important collection, that is map, because after learning this particular collection you will be able to solve most of your programming problems. So let us try to understand the hierarchy. So though map is part of collection framework, but it does not fall under iterable, right? So just note it down that it does not fall under iterable. So we won't be able to use the iterable methods. Okay. So map itself is the root node in case of a map hierarchy. Then map is an interface, so we cannot create object of it. So what do we need? We need some concrete classes. So we have one abstract map which is implementing this map, but it is partially implementing because this is abstract map, meaning, for example, if map has 10 methods, maybe abstract map is not implementing all those methods. So HashMap then extending this particular abstract map class and providing the implementation of rest of the methods, right? So let us quickly try to understand these three collections, I mean maps, which we are going to cover as part of a series. um, so HashMap, in case we are not bothered about the insertion order, meaning, for example, if we are trying to add the values but we are not worried about maintaining the insertion order, then we go for HashMap. And in case we want to maintain the insertion order, we go for the linked hash map. And in case we want to maintain the sorting order, then we go for the tree map. So this is just a high level understanding, but we will be diving deep into it. So in current lecture, the focus would be hash map and various methods that we need to use. And in the next lecture, we'll be covering linked hash map and tree map. Okay. Now, before we move on, let us try to understand what is the need of map, right? So, as we have just covered that using list and set, we can store duplicate as well as unique values. But what if we want to store the name of employees as well as their ages, right? So for that purpose, list cannot help us, even set cannot help us. So for that purpose, in order to store some keys, some data, and then we want to store some different value for that particular element. So for example, in case we want to store the name of employees and we want to store the ages of employee, so in that case we go for the map. So now let us, so at a high level, just consider like map is used to store the key value pairs, right? This is just a high level understanding you can understand for now, but when we will demonstrate it, you will get good understanding. These are some of the attributes of map. Map contains unique keys, and map can contain multiple null values, but it can contain only one null key. So we'll be covering each one of these during the demonstration. Now I have tried to visualize how a map look like, right? So as we discussed, map contains key and value. So for example, I want to store name of employee and their respective ages. So what I have done, this is the key, Prince is a key, and 32 is value. Similarly, Raman is a key and 31 is a value, right? So this is name and this is age, right? Now we just discussed that keys are unique, so we can call it like this is a key set because set contains the unique values, and these values can be duplicate as well as unique because two-person can have same name and can have different ages as well. So I'm just referring it by collection, right? And this particular key and value become one entry, and the entire key and value, meaning these multiple entries, become an entry set. So I'm just trying to give you some good understanding at high level, right? Now, how map internally works, what actually happens, and how it stores. Though it is not part of current series, but I'm just trying to give you some high level understanding how it internally works. But in case you are really interested in how they internally work and how the entire process takes place, I can create a video on that, but you can provide me comment in the comment section. Now, in order to initialize object of any class, what we need to write new hash map. So this is how we initialize the hash map, right? Similarly, we can do linked hash map and tree map as well. So as we are covering hash map, so I am creating the object of new hash map, and as soon as we are creating the object of it, we need some reference variable. So this is nothing but map, because hash map is the child of map, so we are providing map in the left side, right? And in map we provide key value in the form of angle bracket. So this is how we initialize the map. So as soon as we write new hash map, what happens? By default, it initialize one array of 16 buckets starting from 0th index to the 15th index. So one array is created in the memory, right? Once this array is created, the next thing is when we want to add value into the map. So for that purpose, we use a put method, right? So put is a method to put the values, right? So as we discussed that we want to store key as well as respective values. So this is the syntax of adding the value into key and value into the map, right? As soon as we type in this particular, or we write this particular statement, and this particular statement is processed during the programming, what happens? Corresponding to this key, one hash method is called and one hash is generated, and corresponding to hash, using some internal mechanism, it generates one index ranging from 0 to 15th, right? And whichever the index it will get on that particular section, or in that particular bucket, that this particular key will be assigned and respective value will also be assigned, right? So this is how it internally works, right? We will try to understand from the demonstration point of view as well, right? Now we have covered the map interface, we covered hash map. In case we want to we are not worried about insertion order, then we go for hash map. And in case we want to maintain the insertion order, we go for the linked hash map. And in case we want to maintain the sorting order, we go for the tree map, right? Now let us try to understand from the demonstration. Okay, what I've done, I'm simply using a maven project, right? Wherein I'm using a pom.xml. So this is the basis of any maven project, and I'm using selenium for and WebDriver manager as well, right? So now I'm coming to the map demo, which is a class that I have created, and I have one main method as well, right? Now I'm just quickly trying to show you what we were doing in case of list and set. So we were writing like this, new array list, and then we were adding list.add, right? And we were, for example, adding prince, right? But what happens in case of map? So I'm just commenting this section. I was just giving you a glimpse, a remind. Uh, Now how to uh, initialize a map? So new hash map, and this is key and value. If you hover over here, it is says key and value, it is expecting key and value, right? Now once we have initialized the object, what we need one reference variable. So map of this, and let us give it name hashmap hm. Right, you see that it is giving some error because we need to provide the values. So for example, string comma string. So what does it mean? In case I want to store key as a string and value as a string, I will be using map of string comma string. In case I want to store key as a string but value as an integer, then I'll be using map of string comma integer. And this particular section is optional in the right side, but we can provide it for the readability purpose. Right, now let us try to understand what it is doing actually internally. So when we go inside, so you see that it constructs an hash map with default initial capacity is 16 and default load factor is 0.75. What does it mean? It means by default it will be having 16 buckets, meaning 0 to 15, and the default load factor is 0.75. What does it mean? If we will multiply 16 into 0.75, it will become 12. So as soon as this particular map is loaded with 12 values, the array size will be increased, it will be resized. Okay, so this is what is load factor, right? Now let us try to understand how it internally work, whatever we just mentioned. So I'm simply going to add prince comma 32, right? Now I'm going to uh, go inside the definition HashMap, because we are talking about HashMap. So I'll go into the implementation of HashMap. So you see it is internally calling put value, and before that on the key it is calling the hash, and here also what it is doing key dot hash code. So this is how they are generating the hash code, and now using this hash code internally they are generating an index and assigning the value, right? So this is how it internally works, right? Now uh, this is how we add the values. So how to add the value, this is how we add, right? hm dot, let us say I want to add some more value, Amit comma 31. Similarly hm dot put Rohit comma 30. hm dot put Virat comma 29, right? Now we talked about that it does not maintain the insertion order. So let us try to understand what does it mean. Now let us see. So if I'll print it, we will see that it is not maintaining the insertion order. So you see we added Prince on the first place, but it is printing Rohit on the first place. So it means whichever order we are adding the values into it, it is not maintaining, right? So for that purpose, we use the linked hash map. So that we'll be discussing in the next lecture, right? So far we covered about the internal implementation. We covered about not maintaining the insertion order in HashMap. The next thing is it contains the unique keys, right? So how to confirm that? So for example, I'm again adding prince, but this time what I'm going to do, I'm going to change the value to 33. And now let us run this. Now you see that Rohit is 30, Prince is 33, Amit is 31, and Virat is 29. So you see at first 32 was added, Prince was a key added, and 32 value was added. When you add a different value, right, new value, what happens in that case? In that case, the value would be updated but key will be maintained, and internally the unique keys will be maintained, because you see that we don't have multiple entries for Prince, we only have one entry. So when we want to replace something, we use this concept. For example, corresponding to one key we want to replace some value, then we use this particular concept, right? Now we have understood that it maintains the unique keys. Can it contain null values, null keys, I mean? So for that purpose I'm just simply adding 34, and I'll try to print in this case. So we just mentioned that it can contain uh, one unique keys, one null unique key, right? This is what I'm just showing. So it will print that, right? Can it contain null values? Yes, it can contain null values also. So you see it is saying like that, right? So this is what we have covered. Now we have covered like I'm just commenting the irrelevant lines. Now we have covered how to initialize the map and how to add values into the map. Next thing is how to get the values. So there is a get method using which, for example, corresponding to name, I want to get the age. So what I'll simply do, I'll simply run this, and so I'll simply run this, and when I'll run this, what will happen? Corresponding to Prince, I'm getting age 32. So you see that we are trying to get the value with respect to key. So this is how we can get the value. Then there is a method contains key as well as contains value, right? So these are used in case you want to use some condition. So does it contains Prince key? Yes, it contains the Prince key. So it will print true in this case, right? Does it contains value, let us say 32? So this time also it will print true, right? So these are some of the methods that we use for the condition purpose, right? Now what if I provide something irrelevant? Let us say I provide 18, which is not the value we provided. So in this case it will return false. So these are some of the methods which will be useful during the programming, right? So I'm just giving a glimpse of it. Now, as we have just understood like how to initialize the map and how to add the values into the map and how to get the values into the from the map, next thing is how to iterate the map. First thing is we cannot iterate the map directly using the iterator. Why? Because if I go inside map, so we see that it is the topmost node or topmost interface in this hierarchy, while when we go to list and set, they fall under iterable, right? So we cannot use the iterator in this case. So how to iterate the map? So there are like multiple things. So in map we have multiple methods. One is entry set, right? So what does entry set returns? It will give you map entries. Entry set means set of entries. So this is the enhanced for loop that I'm using, and on the right side what do I need? Map dot entry, right? And which type of entry I need? Because I have initialized the map of string comma integer, so what I'll be doing, string comma integer, and I'll be giving it some name entry, right? Now what will be doing, let us print entry dot get key, because entry has these methods, and value entry dot get value. Now when we'll try to execute this particular for loop, what will happen? So it will print the values, key as well as value. So you see that we are able to print the keys and values. Now the next thing is, what is the other way to iterate it? So the next way is using the key set, right? So now again I'll be using the like for loop, and this time I'm going to use hm.keyset. So what are the keys? Keys are nothing but these are the strings, right? So when we go by set key set, it returns the set of keys. So keys are in this case like string. So what is the return type? It would be set. So what do we need on the right side? It would be string, and I'm going to give it name key, right? Right, because this is set, so set will be serving values one by one from right to left, and key set is set of string, so I'm just simply providing string in the left side. Now let us say I'm printing key is, this is key, right? And we just discussed about another method, that is value is using hm, because this is the hash map dot get and key. So when we will execute this particular case, let us try to understand what will happen. So you see it is printing key is Rohit, value is 30, key is Prince, value is 32. So this is another way, and here on this particular thing we can apply iterator, and then we can use the concept of while loop as well, because hash this key set is nothing but a set, and on set we can apply the iterator, right? So we cannot use iterator directly onto the map, but we can do it on the key set, right? Now the next thing is there is another method hm.values. So as we discussed, it will give collection of integer in this case, because what are the values in this case? These are integer, so it is collection of integer. So when it is integer, what do we need in the right side? We need integer, and let us say I'm giving the variable as value, right? Now what we will do, so we will print the value. For example, I'm just printing the value. So this is how we can print the value as well, right? So these are the multiple ways we want to iterate the loop, right? Now we have understood how to initialize the map and how to add values into the map, how to get values in the map, and how to use contains key and contains value method. The next thing is how to use it into the test automation. So let us understand the same using one example. So this is the class that we are using, right? This is the page, sorry, web page we are using, or sample application we are using for the collection. So what in the previous cases we were just storing the last name. For example, I want to store last name and their respective email ID. So what we will need, first of all, we will have to like launch this particular URL. We will have to go here, and then we will have to store Smith and then respective value, similarly batch and respective email ID. So this is what we are going to do now, right? So I just showed you that I'm using the Selenium for, right? So what I'll be doing, first of all, I need one WebDriver instance, WebDriver driver equal to new Chrome driver, right? Now we have initialized driver, right? And you see when we are using Selenium 4, we don't need to use WebDriver manager concept, right? Dot Chrome driver dot setup. We don't need this line. Neither we need system.set property line to set the path of the Chrome exe, right? So this is something interesting which Selenium 4 has introduced. In case you want to understand more on this, I have created a video on this that you can use for the reference, right? Now we have initialized the driver. So the next thing is to launch the URL. So we will be going here, and I'll be coming here and copying this particular URL and driver.get. Now the next thing is, what do we need? So we need to come here, right? So we have written the same code earlier, right? So I may be using, so you see that I need to first of all need to reach till this T body, and under this these are the rows one by one, these are the rows, right? So for that purpose I already have one XPath available, right? I'm simply going to use this, and this time I'm going to print it. So if you see that this is the XPath, right? Now I'm going to use this particular XPath. So driver dot find elements, because these are the list of elements, and by dot XPath, because we have XPath. And now if you hover over here, this is list of web element. So on the right side, on the left side, sorry, I'll be using list of web element, and I can give it name rows. Right, now what do we need? We need to iterate it one by one. So we need rows on the right side, and on the left side what do we need? Web element, because these are list of web element. And now what we would need, right? First of all, we will be getting element one by one. So we need what we want to do, because what we are looking for, first of all, we are iterating these rows, and during iteration we want to get last name and we want to get the email. So how to get it? So I'm simply going to show you. So we got the XPath, that is what we discussed just now, right? Now td1, right? td1 is nothing but the last name, right? And td3 is nothing but the email, right? So this is what we are going to use, right? Now we got the element. So using element itself we can find the uh, for example, the child element by dot xpath, and in first case I'll be using td of 1, and I can give it name string last name, right? And now I'll be, because this is the element, we need the text as well, so I'll be using get text. Similarly, I'll be copying it and I'll be pasting it here, and this time I'm going to give it name email, and I'll be going to change it with td3. So we got the last name and email. The next thing is we need to put into the map. So we will be initializing the map of string comma string because both are the strings. Map comma string hm new hash map. You can give it some relevant name, last name, email, map, right? So last name, email, map. So we just discussed like how to add value to the map. So we are iterating the list and list of element, and then we want to add the values into the map one by one. So we'll be using put method. So what do we need in the key? Last name. And what do we need in the value? That is email, right? Now after the iterations are completed, what do we want? We want to print the map. Why? Because we just want to verify whether the values are inserted properly or not. So you understood? First of all, we are initializing the driver, then we are launching the URL. We are going to the rows table, then we found out the rows. We are iterating the rows, and then we are populating the map from that row, and we are populating it with last name as a key and email as value. Right now, I'm going to run it to understand how it works. So you see, it will first launch the Chrome browser, and it will get the values, get the last name and then the email, and it will populate the map. Now let us see that it has populated like this. This is key, this is value, this is key, this is value. Now let us confirm the same, right? So I'm going here and let us confirm the same. So we have Smith and J Smith, batch, F batch, do, J do, Conway, T Conway, right? So whatever the last name that is available in email. So let us confirm the same. Smith, J Smith, Conway, T Conway, batch, F batch, do, J do, right? So this is how we can use it into the test automation, right? So this is what I wanted to cover as part of current video. I hope you would have found it really very interesting, though it was lengthy. So today we are going to cover another important collection, that is linked hash map, which is nothing but extension of hash map. So in hash map we were unable to maintain the insertion order. So linked hash map works uh, work out in this case, meaning it stores key value pair. Along with that, it maintains the insertion order as well. Now let us try to understand how it works, right? Or what do we mean by maintaining the insertion order? So last time what we were doing, we were creating object of hash map, right? And then we were assigning it to the map reference variable, which is like parent string comma integer, and we were defining some reference variable. Once after this, we will import it, and then what we were doing, we were adding some key value pair using put method. So let us say we were adding prince comma 32, and then we were adding, let us say, map dot put sumit comma 31, and likewise we can add third more entry, let us say Rakesh comma 29, right? Once it is added, so the next step is let us iterate it to check whether it is maintaining the insertion order or not. So for that purpose, I'm going to use one method of map, that is entry set, which will give me set of entries. Now I need to get each entry one by one. So for that purpose, I'm going to use this particular syntax, map.entry string comma integer, and this is entry, right? uh, Now what I'm going to do, I'm going to print the key of each entry dot get key plus, and entry dot get value. So this is what I'm going to print now. Now we will see like what actually the mean of not maintaining the insertion order. So in this case we are using hash map, so we will observe when the output will be printed, right? So you see that prince comma 32, which was added first, and sumit comma 31, which was added second, but it is appearing on third number. while Rakesh comma 29 was added on third position, but it is appearing on second number, meaning it is not maintaining the insertion order. What if there is need to maintain the insertion order, meaning whichever order we are entering key value pair, we want to maintain the order as well. So we will simply convert the hash map into linked hash map. So this is the only change that we need to bring in, right? Now rest of the code is going to be same. We are using the same syntax to add the value key value pair, right? Now I'm going to again run this particular code and we will observe the difference, right? So you see that prince comma 32 was added first, so it is appearing at first position. Sumit comma 31 was added at those second position, so we are able to retrieve it on the second position. Similarly Rakesh comma 29, right? So this is how we can use linked hash map to store key value pair and maintain the insertion order as well, right? Now, the important question is where to use it into test automation. So, wherever there is a need to store the key value pair, and along with that, there is a need to maintain the insertion order, in those cases, we go for the linked hash map. Let us try to understand it from the real time example. So, for example, we are working for one e-commerce application and we are validating one functionality of add cart. So, let us say we are adding at first Reebok shoes as the Reebok shoes we are adding. This is the item we are adding and this is the quantity we are adding. Then what we are doing, we are adding floater as another item and its quantity 2, and baby soap and its quantity 4, right? Now what we want to validate is we want to validate whichever order we have added value into the cart, they should appear in the same order, right? So for that purpose what we can utilize, so we can use linked hash map here and we can store item as a key and quantity as value, and using linked hash map we'll be able to store in the same sequence it got added, right? So in these kind of cases we go for the linked hash map. Now there is another example that I'm going to demonstrate. So for example, in previous example of HashMap, we were storing this as a key and this as a value, and this as a key and this as a value, right? One by one. But we were not maintaining the insertion order, meaning we were not worried about the insertion order of this particular case, right? So now let us try to understand the same. Okay. So in the previous example, we already I already covered this part. So what I'm going to do, I'm simply going to reuse the same code which I used in case of HashMap from the Selenium point of view. So I have uncommented this section now and I'll explain you what is happening here. So I'm importing the packages, right? Now what we are doing, first of all, we are instantiating the object of Chrome driver, then we are assigning it to WebDriver interface. We are launching this URL, and after that using XPath we are locating the list of rows, right? So what we are doing, we are getting the list of rows, right, which is nothing but list of web element. Now using the for loop at line number 52, what we are doing, we are iterating the rows and we are getting each row one by one and assigning it to element, and using this row, right, using this web element we are trying to get the column, right? So once we got this particular row, so using row we are trying to get this column, which is first column, and this is third column, right? And then we are storing this as a key and this as value. So this is what we are doing. So last name, so we got the first column, we are keeping it in last name. So after getting the last name column, right, then we are getting the text because we are mostly interested in this particular text, so that's why we are using get text method, and we are storing in last name. Similarly we are doing for the email as well. So for every element it will happen, and then after we are putting it into a map. So this is the map that I have created. So for now let us convert this into hash map, and then we will come back and discuss about linked hash map, right? So this is what is happening. At last what I'm doing, I'm simply printing the hash map which is got populated from this table. Sorry. Now what will happen, it will launch one Chrome browser and it will get the key value pair and store it, right? Now if you will observe this particular key, right, Smith, and this is key and this is value, right? Smith, this is key and this is value. Similarly convoy, convoy is the fourth entry, but it is appearing on the second position. Similarly, batch and f batch, it should appear on second, but it is appearing on third position. And do jdo key value pair is appearing on the fourth position, meaning it is not maintaining the insertion order. So what to do to maintain the insertion order? So for that purpose, I'll simply convert this into linked hash map, right? And now let us see. I'm again going to execute the code and we will observe what is happening this time, right? So it will again launch the Chrome browser, wherein it will launch this particular URL and it will store the key value pair. So if you will observe this time, Smith is appearing, Smith and JSmith key value pair is appearing on first position, and batch and fbatch key value pair is appearing on second, do and jdo is appearing on third, and convoy and tconvoy is appearing on the fourth position. So this is where we can use linked hash map. So wherever there is a need to store the key value pair and there is a need to maintain the insertion order as well, so in those cases we go for the linked hash map.
And
So
today
this is
we are going to discuss another important collection, that is tree map, which is again used to store key value pair like hash map. But this time, along with storing the key value pair, it will maintain the sorting order as well based on the keys, right? So using tree map, we can achieve two type of sorting for the keys. One is natural sorting and another is customized sorting. So natural sorting is achieved using the comparable and customized sorting is achieved using the comparator, right? So comparable and comparator are two interfaces in Java which is used for the purpose of sorting. So in today's lecture, we'll be discussing about natural way of sorting using comparable. And this part, that is customized sorting, I'll be covering once I'll cover comparable and comparator in the sorting series of collection. Post completion of comparable and comparator, I'll be covering how tree map can be sorted based on the customized sorting, right? How tree map can store the key value pair based on the customized sorting of keys, right? Now we have understood that it provides two type of sorting. Now let us try to understand its hierarchy. So map is the rootmost interface uh, in map collection, where then we have abstract map, which is an abstract class and provides implementation of some of the methods of map. That's why it is abstract. And then after, there is a tree map, which is a class and it is extending abstract map, and whatever methods not implemented in abstract map of map interface, tree map would be implementing them. On the right hand side, we have sorted map, which is an interface, and it is extending map interface, and on top of map interface it is adding its own methods, and we can say declaring, because this is an interface, so it is declaring its own method for the purpose of sorting. And then we have navigable map, which is extending sorted map, and on top of sorted map method it is adding its own method for the navigation purpose. And then after, at last, tree map is implementing navigable map, right? So we can say that tree map is on the one hand extending the abstract map, and on the right hand side we can say it is implementing the navigable map. So now let us try to understand the things one by one. So let us jump onto the practical demonstration. So I have created one tree map demo class, wherein I have created one main method. Now I am going to create object of tree map. So this is how we can create object of tree map. So as soon as we create object of tree map, we need to assign some reference variable as well, right? So I'm going to use parent map as a reference variable. So for that purpose, I'm defining the reference variable of map, and I'm going to give it name tm, this name, which stand for tree map, but you can use any name, right? Now let us try to understand the hierarchy. So I went inside tree map, and you see that it is extending abstract map. So this is just, we discussed that it is extending abstract map, and along with that it is implementing navigable map. This is what it is doing, and navigable map is further extending sorted map, and sorted map is further extending map, right? So this is how the hierarchy look like, right? Now there are two type of sorting we discussed. One is natural sorting, which will be covering in current lecture, and customized sorting will be covering once the comparable comparator part is covered in the sorting series of collection, right? So now let us try to understand the natural sorting, right? So as soon as we create object of tree map, what happens? So by default we are calling this particular constructor, and you see that construct, what is the official documentation? As soon as we create object of it, it says as soon as this particular object is created, construct a new empty tree map using the natural ordering of its keys. What does it mean, natural ordering of its keys? I'll be just discussing. Now let us move on to the next statement, which is saying all keys inserted into the map must implement the comparable interface. It is saying must, right? So it is saying like tree map can be used for those cases where the keys we are using should implement the comparable interface. Now, as we have created map of string comma integer, so string is a key, so it should implement comparable, only then we'll be able to use it in the tree map. Now let us go inside tree map, inside string, sorry. So I'm going inside string. So if you see that string in Java is already implementing comparable, right? And if I go into comparable, this is an interface and it has compare to method, right? Right. So once when it is implementing comparable interface, so it will be implementing the compare to method. So if you go inside this compare to method, so this is where the string is providing the implementation for the natural sorting. So if you will compare here, so this is what they are doing, and they are uh, giving the natural sorting. So this is how a class define it sorting by implementing the comparable interface. That's why it is known as natural sorting, because class after implementing the comparable interface provide some sort of sorting. That's why it is known as natural sorting, right? Now let us try to understand the same by adding the key value pair. So now I'm going to add, let us say, prince comma 29, and then let me add put Amit comma 31, and now let us add tm dot put, and this time let us say Bhavya and 24, right? Now when we will print this, what will happen? So you see that it is appearing, it is storing the key value pair, and along with that it is maintaining the insertion order based on the keys, that to a natural order. So natural order in case of string is implemented is ascending. So Amit is appearing first, then Bhavya is appearing, and Prince is appearing, right? So this is how we can use tree map. Now the next question is, can we insert null key in case of tree map? So let us try the same. I'm adding null and I'm adding value as integer, right? If I'll run it once again, what will happen? So you see we got null pointer exception. Why? Because if we will insert null key in the tree map, because tree map maintains or provides sorting. So in order to provide sorting, we should have two keys of same type, meaning string, there should be two string, two integer, right? But how this null can be compared? That's why we cannot insert null in the tree map. However, we can insert null key in case of HashMap as well as linked HashMap. Okay. Now we covered that tree map is used to achieve the sorting, and it will achieve the sorting for those keys which are implementing comparable interface, right? So string is already implementing the comparable interface. So what if we use a key which is not implementing the comparable interface? So I have used this particular custom key class in the past example, one of the past examples. So I'm going to use it again. So this is one class. If you will notice, it is not implementing comparable, right? So what I'll do, I'm going to comment this section now, and I'm going to replace this string with custom key, the new class, right? Now when I have did this, now I'm going to add value. So how to add the object of custom key? So using new custom key, and I'm going to pass prince. Now I can pass my value. So this time when we will run this particular program, what will happen? So we will see, we will get class cast exception. Why? Because tree map statement itself says that it needs only those keys which are implementing comparable, but in this case the custom key is not implementing the comparable, right? So we covered what is tree map, how to use tree map, to store key value pair and how to like how do we get the result. And then we discussed like it does not allow null and it does not allow those keys as well which are not implementing the comparable. Now the next question is, which is very important, that where to use it in test automation, right? So there are like multiple areas where we can use it in test automation. For example, you are executing your test cases, right? So when you will generate your report, it will be in some random order. So what you can do after execution of each test case, you can maintain test case ID and its respective result in the tree map. So by which you will be able to track it based on ID and the status, right? So it will be in sorted way, right? So now the next example that we are going to demonstrate. So for example, this is one sample application we are using, and it is the screenshot of that particular application. And this is the table, and it has some sorting mechanism, right? So as soon as, first of all, when we will launch this particular web page, it has this last name in the random order, right? So as soon as we click on this last name, it will appear in sorted way, right? Corresponding to this sorted last names, its value will also be changed, right? Because previously batch was on fourth place, now batch has came onto the first place because of sorting. So corresponding to batch, this particular email ID will also be updated and will be placed here. Now how to verify it? So for that purpose, we can use linked hash map as well as tree map. So let us try to understand the same, right? Now what I'm going to do, I'm going to the previous example which we used in case of linked hash map, wherein we dealt with this particular code. I'll be explaining the same. I'll be copying this part and pasting it into the current example, right? Now I have copied it and pasted it. Now I'm going to this particular site. So what we are going to do, first of all, we are going to initialize the Chrome driver, and then we'll be launching this particular URL. And on this particular URL, I'm going to click on last name, right? For this purpose, I have already find out the XPath. Once after getting the once after sorting this, I'm storing it into the list, and then I'll be comparing it, right? Now what is like let us try to understand first, right? So what we are doing here, we'll try to replicate the same here. So we are initializing the Chrome driver object, new Chrome driver, and then after assigning it to web driver interface using driver.get, we are launching the URL, and then after, this is the XPath of this particular last name. So as soon as we will click on this last name, the results will appear in the like sorted order. Then after, what we are doing, we are storing it into the rows, right? So I am storing all the rows into the list of web element, right? Then I'm traversing the list of elements one by one and finding the column 1 text, which is td1, and then the td3, right? This is what I'm finding, and at last what I'm doing, I am storing it into the linked hash map. So this is the actual result, right? So linked hash map, using linked hash map, what we can do, we can maintain the insertion order. So now this insertion order should be the sorted one, right? So what I'm going to do, I'm going to use it in the use the linked hash map. So along with this, this is actual result. Along with this, I need the expected result as well. So what is the expected result? I'll simply copy paste this section, right? And I can use tree map this time instead of linked hash map, and I'll give it name tree, right? And this time, along with storing link values into the linked hash map, I'll put it into the tree map as well, right? So as you know that using tree map, what we can do, we can store the key value pair and it will maintain the sorting of the keys, right? So this is what we have done. We have clicked on this and we are storing in linked hash map so that we can get the actual result, and actual result is sorted one. Now we need the expected result as well, which we can pass either from the test data, but in this case I'm directly using test a tree map here. Now the next thing is I'm going to print it, right? I'm going to print the tree map, and we will see that both have the same order, right? So this is just for the printing purpose, but for comparison of it, you will have to write different iterators in both the cases, and then we'll have to compare. But I'm just going to show you like how it look like. So it will launch the URL and it will click on last name and it will store the value. So this is the output of linked hash map, which is the actual result, and this is the expected result. So expected result was the sorted one using tree map, And this is the actual result which is using the linked hash map, because linked hash map can store the insertion order. So this is how we can use tree map um, in the real time example, right? Now the question is, next question is, what is the difference between hash map, linked hash map, and tree map? So we have already covered hash map, linked hash map, and today we covered tree map. So hash map is unordered key value pair storage, meaning it stores the key value pair, but it does not maintain the insertion order. And it can store one null key, and internally it is based on hashing technique. While linked hash map, it is an ordered key value pair storage, meaning along with storing the key value pair, it maintains the insertion order as well. And similar to HashMap, it can also store null keys, and it also internally uses hashing, right? Coming to tree map, it stores key value pair. Along with that, it maintains the natural sorting order of inserted keys, and it cannot have null key, which we just demonstrated. And internally, it uses red black tree, which is a self balanced binary tree. So this is what I wanted to cover today. So let us quickly recap what we covered. So we covered what is tree map, and it provide two type of sorting, natural and customized. And we covered natural sorting as part of current lecture. Then we discussed about the tree hierarchy. Then we discussed that tree map cannot have null keys, and we discussed where we can use it into test automation. We discussed about this particular example wherein we used linked hash map as well as tree map for the actual and expected result. And at last, we did the comparison of hash map, linked hash map, and tree map. So this is what I wanted to cover, guys. Thank you for watching, and I would request you to please like, share, and subscribe in case you like the content. Thank you.